Hi, my name's James Gress. I'm the North America DevOps Solution Factory Lead for Accenture. I'd like to thank Tampa Bay Tech for allowing me to present at this Powered Up Summit. To give you a little background about me, I lived in Tampa most of my life. It has been great to see the Tampa area grow in the technology space. Especially over the last 5 years, we've seen a huge growth and feel that we are on the verge of becoming a tech hub. I'm especially fortunate that I get to live and work in a great city and still get to work with top Fortune 500 companies all over North America, working on cutting-edge DevOps practices. Today, I'm going to talk about DevOps self-service across the enterprise, as we have been seeing this trending amongst top organizations, and take a look at how many organizations implement and do this today. Getting us started, most companies at this point know there's value in DevOps and are in the process of implementing and maturing in the space. Talking to many IT leaders and practitioners, the definition can vary. However, there's usually a common theme. If we take a quick look at a few published definitions, you can see that it breaks down into closer alignment with Dev and Ops, with the goal to provide business value faster while still maintaining quality. This is done by reducing toil and adding automation. However, automation alone does not make good DevOps. At the end of the day, we want more hands working on the business value for our customer than needing to have folks repetitively do activities over and over. As we talk about DevOps, my scope in this will also include all areas of the software delivery lifecycle, including DevSecOps, security, integration testing, performance, and really everything from the development of code to getting into production with all the quality gates in between. Here's a typical technology footprint we see many organizations have today, where a company, depending on their size, could have hundreds of different project teams. This is meant to be a high-level sampling to show that different projects are varying levels of maturity and could have chosen different tools. One common thing we see amongst different project teams within an organization is they start to share tooling. For example, they might want to share a Jenkins instance or a SonarQube instance, which will start to link those two projects together from a dependency level, meaning, say, if Project X is starting up a brand new project, wanting to use their Jenkins and SonarQube from Project A. Now Project X is dependent on when Project A is starting to decide when to upgrade their SonarQube and or Jenkins and or put maybe a different feature in from a plugin support. Also, in this landscape, we see that project teams are now having to support more and more applications. Overall, maintaining these tools and platforms aren't a set it and forget it activity. They require managing and maintaining tooling, managing security vulnerabilities, licensing, acquisition and renewal, backup policy and disaster recovery strategies, and much more. All these things are necessary, but do take time away from development teams if they're supporting these tooling themselves. So what do we really need? Rapid access to the right tools, DevOps patterns to support the technologies. Two tools I really like to use. On the AWS side, we have AWS CodeStar. On the Microsoft side, we have Azure DevOps. In both cases, you get to select a technology, select a deployment mechanism, and within just a couple of quick steps, we get not only a sample reference application out on a repository, but the DevOps pipeline to support that application, as well as a target environment in which to deploy out to. Where we see a lot of organizations extending on top of this is being able to add a self-service capability onto these services. This way they can ensure that these services follow their organizational standards and security requirements for deployment and consistency every single time. Additionally, they might want to add some additional quality gates like code quality, performance testing, security scanning, and integration scanning to the automatic deployment of these technologies, as well as they might want to extend technologies that aren't on this list like SAP or Salesforce. For Accenture, we've also created a self-service and DevOps platform called ADOP to be able to support an organization as large as Accenture, which currently has about 480,000 members. This platform we call ADOP. And to give you an idea of the size and scale, we currently have about 40,000 active members within the platform, hundreds of Jenkins pipelines, as well as over 600 different projects utilizing this service. Let me switch over to the demo side and show you around a little bit. So this is the Accenture DevOps platform, or ADOP. In this demonstration, I'm going to show a simple use case of being able to start up a brand new project, being able to provision out the right services for that project, as well as apply a DevOps pattern to that project to be able to support their application. We've made it very easy. We can simply come out here to create an ADOP enterprise project, collect some simple information, project name, cost center code. We'll also set up the permissions so that every time we start setting up new services that are applied to this particular project, it'll inherently grab these permissions from not only a user, developer, or admin perspective, so our teams can instantly start utilizing them. From here, we'll get a dashboard, and from this dashboard we'll have quick links. This project was already set up ahead of time. This is the one I use on a daily basis. So it has quick links to the projects and services that I use. It has event logs from the last couple of things that were provisioned. Has a what's new from a ADOP perspective, so we can communicate out to the users, and some quick add buttons. But if I follow the use case of needing to start provisioning services, and from this services list I can see all the services that I've originally provisioned. But if I was starting up a brand new project, even though I might have some of these services provisioned, a new project, I would likely want to go out there and add a brand new Jira project and Confluence space to keep all of those user stories and architectural designs and collaboration areas separate from the other applications. So if we think about a project manager quickly coming in here, needing access, the first thing they're going to want to do is start creating their user stories, start creating their Confluence spaces with their designs, as well as starting to request maybe a brand new Jenkins master or a new Bitbucket repository, OpenShift project, code quality tools, or any of the other services that you see here. And the great thing is as these services are created and added to the platform, they'll have the same security standards and operational standards that are set by our organization. So once we have access to all the tools, one thing that I find very powerful with this platform is the ability to add what we call a component. And what a component is the ability to automate the automation. So this is going to give us, in a lot of cases, a sample reference application. It will give us that application loaded up to a repository. It will give us a pipeline to support that application, automatically wired into all of the quality gates we've defined, like SonarQube or Nexus or Black Duck. Give us sample unit tests, give us sample integration tests. It will also give us the infrastructure as code in some cases, depending on the application type, to be able to spin up that application and to be able to deploy it in an automated fashion. And essentially everything you need to be able to quickly click on a few buttons and have something up and running so that a developer can go out to the code base or that repository and start adding business feature. And as they commit, they're going to start going through all of these quality gates right from day one. And we can see from this page that we have a number of different patterns to support the different technology types across many different types of projects. For example, we have some that's very commonly used from a Java perspective, as well as we're seeing a lot of uptick from Salesforce and utilizing DevOps to support Salesforce. We also have Oracle, SAP, and if I scroll down here, we can see just how many different kinds of patterns that we have available. So in this example, I'm going to go ahead and click on the OpenShift Java cartridge. And from here, we can see what a description of this is. If we wanted a link to our DevOps Center of Excellence wiki pages, we can click on this and it'll give us even more information. If I wanted to look at the actual code that provisions this cartridge out or actually does the automation side of it, I can go out and look at the actual code that does this. This also gives me the ability to clone and extend, or possibly even fork and contribute back, as well as any prerequisites that we might have. And since our services are already stood up now, we can simply go select the services and where we want the target components to be. So in this case, I'm going to select the components that were provisioned out earlier, give it a unique name, and confirm that I have completed all of the prerequisites. And from here, I can click Submit. And an automatic process is going to go out there and do all of those things that I had mentioned before, where it's going to automatically go build out a Jenkins pipeline for me. It's going to load up the sample reference application and wire up everything that I need to quickly get started. Because this isn't a PaaS-like environment, I'm not actually going to go and click on this, but I will show you what was provisioned out earlier. So if we go out and look at what was provisioned, we can see that I get quite a number of different quality gates and quite a lot of value being able to do this. So not only do I get the sample reference application checked into my source code repository so I can hand it off to developers to start building things right away, but we have automatic build scripts. We have sample unit tests. We're already wiring it in through code analysis. We're doing security vulnerability analysis. This particular cartridge didn't out of the box come with Black Duck, DevSecOps security scanning, but what we wanted to do is highlight the extensibility so you're not necessarily having to always have to conform to only the steps that are there today. As well as we added in a Jira ticket updater so that if all our quality gates are good, we wanted to be able to add those comments back to the Jira tickets that were used to check this code in, so we can use that as traceability and get some of this information back from all these scans back into the Jira ticket itself. This gives not only the developer quick access and being able to see all the results in one place, but as the business will primarily use things like Jira to see where things are at in the delivery lifecycle, they can also use that as a reference point to see where things are at and see how things are building or what the status of their user story or feature is. And once all that is done, we then publish out to the Docker file and then deploy this out to OpenShift. So now we have a running application sitting out there with that brand new feature added that we can go back and show the business. And in some cases, we can even notify them to tell them that, hey, this Jira ticket has been implemented, it has passed all our quality gates, it is now ready for you to go look at. So just quickly looking at some of the components that make up this and what all that has happened through the automation of getting this created. We have our Sonar Cube automatically wired in, and we can even see our sample reference application has 3 vulnerabilities that we need to go fix. From a security vulnerability scanning, we can see that from Nexus here that we have some critical things that we need to go take a look at, as well as utilizing a PaaS-like service so that we can additionally look at something like Black Duck to see what our vulnerabilities are from that perspective. And then finally, we can go out and see how it was actually deployed and look at the application running within OpenShift. And then finally, what the product owners might see is that feature being done. In this case, we are using Pet Clinic for our demo application because it is open source and readily available, and we don't have to worry about showing any kind of client environments and that kind of thing. I hope that got you inspired to see how your organization can start using something like a DevOps self-service portal. Other trends we're seeing in 2020 from the work we're doing right here in our Tampa Bay Advanced Technology Center is cloud native DevOps. where we start with a cloud native application and use that cloud provider's DevOps services to support that application. For example, using things like code commit, code deploy, code pipeline from AWS. DataOps, where this area has been underserved and can slow down our application release cycles by not having fresh and secure data, as well as how we promote schema changes alongside our application changes to ensure we are removing this bottleneck waiting for manual database updates. As well as continue to see a trend for DevSecOps and container paths or CASs, like using services for ECS and EKS. Here are some ways to stay connected, and we'd really like to hear about the things you might be doing right here in the DevOps space in the local Tampa Bay area. I organize a monthly meetup that is part of the Tampa Bay tech community called Tampa Bay DevOps. We quickly have grown to over 1,000 members and talk about a wide range of topics, including the latest from Synopsys, DevSecOps, GitLab, CompuWare, and modern mainframe development, and new trends like cloud native and DataOps. I'm also a lead organizer for DevOps Days Tampa Bay, which is a yearly conference for DevOps in the local area. We had our first event last year and it was a huge success. We are also in the initial stages for this year, and if you're looking to help organize or volunteer, please keep an eye out on the devopsdays.org site and or contact me directly. Thank you for your time.